Peace be upon you and God's mercy and blessings. God willing, we want to see together how I can design a CID file in Siemens release. Well, now I can have more than one scenario. For example, scenario number one is that you are now an engineer working in the engineering department and you are now in the office. So you start designing a project of your own with a group of Siemens releases. Then you add a new device and choose your device, such as 7SD for differential protection, 7UT for transformer protection, 7SJ for feeder protection, or whatever the release group is on in YouTube. Finally, you take this project and send it to the page. Then the protection engineer works through it on the protection design. After that, they can create a CID page or send this project to the SAS engineer who will start creating the CID page. The second scenario is that you have entered a site and do not have the project, so you extract the releases available at the station and work on the station's project along with the CID file. Alternatively, you give the project to the automation engineer who provided the CID file. Whether you are the station engineer or the automation engineer, one of them will be responsible for the CID file. The third scenario might be that someone else originally worked on this project and it is available on the computer or the engineering PC of the SIS system. As a protection engineer, you enter the station and start by taking this project from the engineering PC and then work on all your releases, including testing and configuration related to protection, in addition to creating the CID file. Regardless of the three scenarios we are discussing, we want to see how I can create my project and how I can use it to make a file for Siemens Relays. Very nice. The first thing I do is design the project, and this project is called Rashut. Then I started designing the project using the relays available here. As an example, I am making two relays, the 27SD522, specifically for overhead transmission line protection. SD522 is specific to overhead. Transitional line protection. So now I have two files. I renamed the first file and called it Overhead Line Relay Protection Panel SO 1 and the second file Overhead Line Relay Protection Panel SO 2. From relay protection between the first and the second file, let's think together. In the previous videos, when we were theoretically discussing the CID file, we said that we have three steps to easily define the CID file. The first step is identifying the logical nodes. And we mentioned that logical nodes are divided into two categories, or there are two types. There is something called standardized logical nodes, and there is another thing called generic logical nodes. And I have an event called the generic logic low, and I have an event called the generic logic low, and I have an event called the generic logic low, and I have an event called the generic logic low, and I have an event called the generic logic low. So now I'm supposed to determine what the signals are that I need to exchange these signals, or even these commands between my relays and the SS system. So how is this done? This is done through the masking input. First, I start by taking the first file I have and begin to open this file offline and say, okay, so I opened the file. What do I have? I have an offlight. Okay, what's the first thing I do before I go to masking? Input, output, and keep in mind that this point is very, very, very important. You must specify from the device configuration which functions you have enabled or disabled. Why? Because quite simply, you might go and do all your work in the masking input-output, and in the end, you might say, for example, I'm going to disable this function. In that case, all the logical nodes or signals that you configured in the masking input-output to use in your CID file will be lost as soon as you disable it. Even if you re-enable it, they won't return automatically. On the contrary, you will need to reprogram them. I might even show you an example of this while we're working, all right? And just to remind you, let's talk now about differential protection, or one of the functions that is enabled, and see what happens in the CID file if you disable it. Very good. So once I've finished enabling or disabling everything according to what's available at the station, I say, okay, and then I open the masking input or Very good. All right, now we want to see more examples together that will be used. Let's say the first thing, let's use one of those available. For example, in the system. So all I have to do is open it. And as we agreed or understood before in the videos, we have on the channel, we have something called, and you have something called, what does it simply mean? You have, let's minimize like this. Okay, you have something called, and you have something called. Here on the left, you have all your items that are available to you, then you have something called. And you have something called. The meaning of the word is the source of what's inside, the one on the column on your left. Where is it coming from? Is it coming from, for example, is it coming from, for example, is it coming from the basic interface system? Is it coming from CFC? Is it coming from CFC? And the destination means the direction it goes to, the signal functions that go to the binary output LED, to the system interface, the SIS, or the standard system interface to CFC and so on. So quite simply, if you understand the meaning of the word source and the word destination, you'll be able to program easily. Let's say now that you have everything, you will find some signals that are actually there. Through itself, you will find that they are all present in what you have on something called, so you can then be able to retrieve because it is in your system or configured to be able to go to the SIS UK system. Okay, suppose I have other signals I want, like for example, the second harmonic. Now, for example, you have a differential second harmonic. So how do I employ it in the SIS system, or how can I identify it as a logical node that I want to include in my data set? Here, I need to start by placing it in the system interface. But if you try to put it in the system interface, you will find that you are not allowed to put it there because it is a signal that exists or is present in the relay. But you will find that you are allowed to put it in something called, generally, it is preferable to place your signals in extended system interface, right? Okay, I will give a signal to the second harmonic and Visa L1, Visa L2, and Visa L3. We have a set of signals, decentralized logical nodes, and I started implementing them in the destination on the extended system interface. All right, very nice. Okay, let's continue. We haven't finished this part yet, and I'll come back to it again. Now, the other thing is that I currently have generic logical nodes. What does generic logical nodes mean? We agreed it could be one of two things, either generic signals or generic logic, right? So, what do I do with anything generic as an organizational process? I come here, right-click on the last group I have, and say, insert group after, and this group, for example, I'll name it SAS signals, so that the name is unique. And I say, okay, inside this signal, I start to see all the signals required of me to put in my CID file. And I begin to add them. See, let's assume, for example, that I currently have a binary input. And let's also assume that I have a specific logic between two binary inputs or a binary input with a timer. Right-click and press Insert Information, then go to the word enunciation and single point and choose single point. Okay, great. Okay, this is the first single point that I want to send to the SES. But is it just this one? No, I also have another single point that I want to send to the SAS, or two single points that I want to send to the SAS, but only after they pass through an end gate and a timer. So I can also set up two more from now. Okay, great. And after the two pass through, they will exit correctly. So this output can be taken as an output as well. No problem. You can take it as an output. However you want, there's no issue, as long as everything is fine. If you want to take it, there's no problem. Or the first fast or the first slow, which means you have the nose or the first slow, like events coming out from you, from what you are doing. All right. So for me, there's no problem with taking a single point, but let's change it so people can see it. Here I have an example of a slow outlet. That's indeed quite nice. So I have two that I am eager to utilize to input into, and then their output definitely goes to this, which I will transmit to. But sometimes it also, in fact, requires me to have one that comes to me. Like, for example, so I also need to start taking mine and put it down here as well. Now I will rename the signals, but as we know, I have something called display text and something called long text. We need to pay attention to these names carefully. Why? Because later, all these signals or logical nodes, when I assign them within the dataset in the CID file, I will notice that I can retrieve them through the names so that I don't have to search for them extensively. We will see this now together. We will identify the first alarm and name it Trip Circuit Supervision Field. We will name the display text Trip Circuit Supervision and the long text Trip Circuit Supervision Field to see the difference between the two names. Then we will identify input 1 and input 2. Focus, 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 focus. Focus, 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 focus. And of course, the long text won't make much difference to me. Right now, I'm not going to use these in SAS, but I will use them for logic. So I will also name them input 1 and input 2. However, the output that will come from me is what I will send to SAS. Let's assume, for example, I will name this, let's assume DC alarm. And we will name it DC alert and we will name it DC protection. We can call it text share, just text DC, and the long text is named DC Allah. Here we might name it, for example, protection and name its long text. Protection. First signal, Trip Circuit Supervision CID. Source comes externally via binary input. Assign it with Trip Circuit Supervision regardless of relay pre-programming, the tuple. Delete and assign binary input per drawing. External through a binary input, so I start by assigning the binary input with Trip Circuit Supervision or with this input. Of course, regardless of the relay's pre-programming, I can delete it all and start from here by assigning the binary input according to the drawing I have. Okay, I will assign them number 2 and number 3. I will name them, for example, let them be number 1, 2, for example, and number 3. Also, the first byte is from the remote input. The input byte comes from the SCADA. This means that the DC comes to you from the SCADA. So here I will make a configuration in the SCADA. And the double point comes to me from the regular input. So it will press X here, and immediately it will send 2 to the input, fixed on the protection IO, protection IO, protection out, or protection out. Nice? Nice. So this is the source of the signal that comes to you from the binary amplifier and the destination. I also want to give to the SAS. I want to program it in the system interface. Not in the system interface, because this is something generic I have done. I write X here. And the name I told you about in the differentiation partition appears with me. I will try it and understand it together. As soon as you told it that you want to put it in the system interface, it came to you and said there's a specific address here. What's this address? Look, read the words we understood in the theoretical talk. Logical device, logical node, data object. This is the arrangement. Remember when we dissected the relay? And we learned that we have something called a physical device. And inside it, there's something called a logical device, which represents control, protection, extended interface, disturbance recorder, or measurement. You call it a logical device, a group of logical nodes. Inside each logical device, you had a set of logical nodes. And inside each logical node, there was something called a data object. For example, if you chose measurement or the state of a breaker. So, for example, you have a data object like breaker open or breaker close. If it's a meter, it might tell you amperes, voltage, or current. Then there's something called a data attribute, which is an explanation of your data. Here, when you first configure it, it asks you what its address will be. Of course, this is something generic, so you are the one who sets it. That's why it tells you it belongs to the logical device called control. If you want to give it a name, you can name it, for example, SAS. You will just call it SAS signal. The generic signal, the GGO, or a group of GGOs, can be programmed according to the number of signals you have. You can place them inside a specific group of a certain set, for example, and so on for another set, and so on. All right, then SBC, SO, what number do you have? Number 1, okay, you've chosen number 1. After that, you go to the next one and tell it to apply. Say, okay, the next one, of course, won't be able to take number 1. It will come up and tell you, for example, number 2, number 3, number 4, and we'll see together So this is the first signal. The second ones, the source was a binary input, but the destination is CFC. I will clarify these two for CFC in this way. After that, for the alert, the source will come from CFC, but the destination in SAS, you will tell it X. This is right, this is for CFC, so I will send both of them to CFC in this way. All right, then we come to the alert. The source will come to you from CFC, but where is your destination? Your destination is in SAS, so tell it X. This is right, it will come to you from there. All right, shall we proceed? Also, the same applies here. You put the number for SSGGI01, but here you won't find number 1. Instead, you have number 2. You put the number for SSGGI01, and you put number 2, 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 and you put number... If you assisted the differential, and 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 assisted the differential device, then all your stuff then, it's number 30. So naturally, something like this, you might take a picture or write it down so that later when we go to this file, as we will see in a little while, you will start to do what? You will start looking for this signal, which is named by this address that you see in front of you. All right? I have the standardized logical node, the generic logical node, the CFC, and the double point. The standardized logical node, and here, for example, I have this type of signal as a generic logical node or a generic signal, and for these two, I will start using them with CFC and output them to an object named Qadar. I also have another type, double point. So you can also see how we chose in the AA double point. All right. So what do I have left to do? I need to go to the CFC and adjust my signal. The difference, quite simply, in the CFC is whether I want to create a new CFC or work with the existing CFC I have. There's absolutely no problem with that. I will open my CFC. I will go to page number 1, and there are videos specifically about CFC that you can refer to if you want to learn how to work with CFC. So quite simply, I can start by bringing in an indicator like this, and then, for example, I can bring in a timer, whatever the logic is, depending on the work you have at the station. Then, of course, you will start with the first signal, telling it interconnection to address, and begin by taking the first input. Then the second input, then the third input, then the third input, then the third input. You might go, for example, to the set of the relay, and you start to set, for example, let's say 3000 milliseconds, which is 3 seconds, for instance. You tell it OK, and you output the connection to the connection to the connection, to the connection to the connection to the connection to the connection to the connection. Take the name you want to use, take the name you want to use, take the name you want to use. Under any group, under the group SAS signals, you are now searching, and here you have a large list. You don't need to go through all of this because you know you're going to a group called SAS signals. Any signal in SAS signals under the word display text name DC, and you say, okay, done. What do? We do a combine, but maybe if you downloaded your blocks in an unorganized way, as we know from previous videos, as I told you in Save, we optimize the run sequence. There is no problem executing the blocks as you execute the sequence, then execute the blocks. Okay, the logic that I explained should be in both the slow and fast PLC. It is present in the slow PLC, and there is no problem explaining it in the fast PLC. There is no problem explaining it in the fast PLC. There is no problem explaining it in the fast PLC. There is no problem explaining it in the fast PLC. We also leave it. There is no any problem. It is not a stone, or not a stone that you will do something with it, or whatever it was. All right, so now you have completed the first part, which is in the logical knot. All right, now I have very important settings that I should adjust instead of closing my file and going back to it again to adjust these settings. The first setting you have is the interfaces. If you open the interfaces, you will find something called redundancy. Inside redundancy, there is something called the operating mode. The operating mode has two types, line and switch. The one I'm currently using is the switch. This means that you have a ring connection between the relays. What does this mean? It means if you have 10 relays in the station, you go from relay 1 to relay 2, then from relay 2 to relay 3, and then from relay 3 to relay 4, connecting them together as if they are a chain. And in the end, Fiber communication appears between the first relay up to the SES switches and the 10th relay up to the SES switches. Thus, it's as if you have a complete ring. If there is a break in this ring at any part, now there are two paths for sending the signals. Of course, each path will now be independent or separate on its own for the group of relays present there. For example, if there is a disconnection between the third and fourth relay, now the first, second, and third relays connect to the SAS, but on their own in the form of an open ring, and the relays from the 4th to the 10th also connect to the SAS in another open ring. All right, then you have the redundancy type, which is RSTP, and we say, okay, here you go, here you go. The second very important setting is time synchronization. Here, the relays you have at the station start connecting to an external GPS. So here we choose something called external, NTP, which is the network time protocol. After that, you start with the no daylight saving and you begin to mark it. Then you have your time or time zone offset, which you start setting to 0, obviously because you have the external GPS. All right, and then what do I say? I say, okay, so now I've made it so that the relay's time will be taken from the GPS. Is that clear? Okay, now what have I finished? Everything. I start closing the file. It will prompt me to save. I say yes. And now what have I finished? I mix the first file with the side. All right. Thank you for watching.